Okay, I just added the formulas to the board in case you guys need them. In case you didn't get all of number 2 written down, it's up there, okay? Number 3, a rider on drop tower falls straight down for 3 seconds. So our time is 3 seconds, right? Assuming free fall with 9.8 meters per second squared, okay? So that's gonna be our acceleration due to gravity, okay? And we normally have used 10, but it says to use 9.81, so we're gonna use 9.81. How far does the rider fall? So we're wanting a distance, right? Okay. We're wanting a distance. So which one am I going to use there? A is acceleration, initial velocity, final velocity. We're wanting a distance. Okay. Okay, so I'm gonna use, instead of a distance, I'm gonna use this formula, I think. I think this is the one I'm gonna use. Make sure you're doing this in pencil. I think we're gonna use the F sub x equals x sub I plus V sub I plus A, or plus 1/2 AT squared. That top right formula on the whiteboard. I think we're gonna wanna use this formula. And here's why I think that. So we have an acceleration, so we have our A, we have something for T, okay? The initial velocity for this, since we're just dropping it, is gonna be 0 because it's starting at rest before you drop it, okay? And then if we have x sub f and x sub I, that's gonna be the same as our distance, right? Because x sub f is our final position and x sub I is our initial position. So the difference in the two is gonna be the distance, right? Okay. Okay, so there's multiple ways to go about this. I'm gonna go ahead and, which way is gonna be easiest for you guys? I'm gonna go ahead and scooch this over. I think that'll make things easier for you guys. Like I said, there's multiple ways you can do it. So if I scooch that x sub I over, I'm gonna have x sub f minus x sub I. That's the final position minus the initial position. If I subtract those two, that's just essentially gonna be my distance. So I'm just gonna write that as D instead. X sub f minus x sub I, that's just your distance. So I'm just gonna write that as distance, this will go away, equals initial velocity plus 1/2 times acceleration times time squared. And now I'm just gonna plug the right stuff in the right places. So I said the initial velocity, if you're dropping something, is gonna be 0 because you're starting from holding it and then you drop it and it speeds up. So our initial velocity is gonna be 0. Our distance is what we're trying to find. And our acceleration is going to be the acceleration due to gravity, which is at 9.8 meters per second squared. So I'm gonna use that 9.81 meters per second squared. And if they don't tell you that it's 9.81, I would just use 10, but since they specified to use that one, we're gonna use that one. Okay, and then the amount of time that it took was 3 seconds. Okay, and we need to square that since it's squared in our formula. Now we're just gonna type this in our calculator and do it. So it'll be 1/2 times 9.81 times 3 squared. So 1/2